Hi class. This lecture is about function templates in C++. As I mentioned a couple days ago during the class, that we're going to study a bunch of topics related to templates. This is first from function templates, and then we'll talk about class templates as well. This particular lecture, we're going to go over chapter 8, particularly from page 247 to page 258 of your textbook. And also we'll go over chapter 9, Lambda expressions as well. They're really related to each other. And then after that, next class, we're going to cover chapter 16. Okay, so we have a bunch of topic related to templates together. So templates, regardless is a function template or a class template, it helps us to provide a design. It's not an instantiation, a design about some kind of logic or some kind of procedure we would like to reuse for a broader range of application. So for example, I can design a template that's for processing certain kind of data structure, but then I can handle different kind of data type. I can handle integer, double, or I can handle a very complex type, such as class post that you were handling in the homework assignment number 5. Or you can handle something like a JSON, and you will see that you repeatedly handle certain thing together, and maybe we can consider to extract that logic or extract that concept or algorithm into some sort of template to handle all this together. And so this is a really nice tool for us to provide a reusability about the code, and the code could be really nicely written, and then people can help that as well, can understand that as well. And of course, just like every other programming language construct, that sometimes template or class template or function pointer, this is very powerful. Sometimes it could be misused and such that make the code kind of hard to understand or hard to maintain, or there's easier to introduce bugs. So we have to be careful. And we'll also talk about another topic after we finish function template and class template. We're going to look at some of the standard template library which you have been using, for example, std vector. And the other one, which is very useful, is called std map. And so we're going to look at this set of topic to support you as extra tool for you to do your program and software development. Okay, let's start with function template. So here is a very simple example. Hopefully this simple example motivate you about why we want to have function template. So the green box on the top, this is a function template. So a function template is trying to provide an abstraction about a function that you can actually handle different type of data. For example, in this case, the function name is called min. And the idea is try to compare two number A and B and try to return the smaller number. Okay, so that's a function, and I could potentially have on the left-hand side, which is a min function for comparing two integer and return the smaller integer, or I can have on the right side, which I have a min function defined, which compare two double and return the smaller double within this two input argument. So I could be writing a lot of such program for every single combination of data type I need to compare, and which it could be a pretty tedious work, and we're essentially doing the same logic. We just compare, and then we return the smaller one. However, we have to deal with this for every single data type. It's not just basic data type, but potentially we compare two person. For example, you compare whether these two person are equal in the homework assignment number 2. So this is a way that we can use template. This is a very nice appropriate situation for us to use template, and such that we will be able to write it once, and after that people will just calling it with a different type of object. So the way we do it is that this is the syntax for template. So first you have to say the word template, that's a keyword. And then you have that's a keyword as well, the smaller sign and the greater than sign. In between there, you have to say the keyword, also type name. Type name is a keyword. And then the T, capital T, is also the parameter that will be, you will just specify like this, but then it will be replaced when you call the function, it will be replaced by the real type. Okay, so that is just declare, say template type name T. So you specify the T in red is a type name. And so now this information is given to the compiler to understand your template implementation below, which is, okay, this particular template, it will return type is the red T, which is the type name. And then it will take two parameters, A and B, and both of them are type name T. So essentially we're saying that you're taking two of the kind of object belong to that type T, or that type T will be as a parameter from the caller of this template, and then it will return the same thing. And inside here, you can see that we'll just implement the logic, return A is smaller than B. That is if then else, that question mark is saying that whether that condition is true. If the condition is true, it's going to ask you the first part of the return that's before the column, and then if it's not true, it's going to return whatever after that column. So that's why it's A smaller than B question mark, A column B. Okay, means that if A is smaller than B, I'm going to return A. Otherwise, I'm going to return B. Okay, so that is a function template. So what I put down here in the orange box and the yellow box is basically the equivalent when you actually provide that type name information. If you provide type name as an integer, it will do the left side. If you do it in the double, it will return the right side. Okay, so this is a declaration of a template. So what you need to do is really just say the green box. You don't need to say the orange box and the yellow box on this slide. Okay, so once you define the template, then you can start calling it. So calling the template is like the middle of the slides. I put it there. For example, assuming x, y are integers, okay, on the on the left-hand side, you can just call min parenthesis x comma y. So the compiler will see this and see that, okay, x, y are both integer, and compiler happen to know already you have a template defined, and therefore the compiler will actually link this call m minima x comma y to the instantiation of the template to come up with an equivalent of the function on the left. So here I have to clarify is that when you define a template, it doesn't mean that that template will definitely translate into a function, because there are just so many types of this type name T you can fill it in. So the compiler need to know where you're going to use this template. When the compiler realize, okay, you're going to use this template at this particular point, and then they will check what is the type name. So in this case, it will check that x and y is integer type. So then at that time, it will generate the code, generate real function that in your object code of this program, that for your program to call that. Okay, so this is the compiler time, is looking at the template and decide what code to generate. So in other words, I'm saying that if you define a template and you never use it, or the compiler couldn't find the match between when you try to call it to match the right type. So it will be either the compiler will give you a syntax error, or if there's no syntax error but simply not being called, then basically there's nothing will be generated for this template. So sometimes the template, even though it's included in your code, it might not be used, which means that it has a zero footprint in your execution environment. So think about template, think about this is need to be addressed at the compiler time. At runtime, okay, we need to do something else as well. Okay, all right. Similarly, let's look at on the right side. I mean, if you call min with double, I mean, in this case, I'm even casting the x is integer. I can cast as a double. So the compiler will say, okay, the first argument is a double. The second argument is also a float or double. Okay, I will match that template, but this time the template type name t is going to be double. And then it basically include this piece of code in the yellow in the object code, and such that when that statement need to call a function, it will actually call that function. So what I'm repeating my message again is that template is being read by the compiler to help us to generate those two boxes or any other boxes in below. And you just need to write that green box once, and the compiler will take care of the rest for you. And with your statement, because if you have a statement such as min xy or min double x and 2.7, the compiler will generate the right code to go with it. Okay, if you don't have those, this template is basically not making any kind of impact to your code. All right. All right. So you can also do this in this slide. You can see that I changed that a little bit. I mean, in between min and parentheses, I add smaller than, double, greater than sign. Okay, this is what we call the explicit invocation. Means that I want to let the compiler know I want to call that particular version of the function, which is double, which means that type name t is going to be replaced by the double type, and it will generate the right side, the yellow box of the double, and then regardless what you put in the argument. For example, in this case, x is integer, and the compiler might actually get confused whether this is really the integer or double version because it doesn't match. But when you gave this instruction double, compiler will not be confused and there's no ambiguity. It will actually do the yellow thing. Okay, and similarly, as I mentioned, that it doesn't have to be the basic type. It could be an object. For example, I want to find out which GPS is actually smaller. For example, I mean, this is related to homework assignment number 2. So I can actually call this function this way. Okay, when I call this function this way, I'm returning a GPS or using this GPS. So the type name will be replaced by the object reference, which is GPS DD, which then generate a code in the sky blue box. It looks like this. And then when you call it, it will actually call that function. Okay, so this is kind of very powerful, very useful for us to understand the template. So here is the syntax for the template. All right, so the template, as I mentioned, you have a template, that's a keyword, and then you between this pair of smaller than sign and greater than sign, within there is you specify one or more type name for the body of the code you're going to specify. So in this case, that you can actually specify one type name for the return type, because sometimes a function template, they're going to return something like return a bool or return an object. So you actually have a return type you can specify. And then you can actually specify there's multiple arguments that each of them was a different type. So you can actually create a function prototype with variety of object combination with a lot of things together. I mean, for example, I could potentially create a template looks like this, which is a full template, and it basically call the return is a JSON object pointer. It takes the first parameter is a pointer to a person. The second parameter is a pointer to JV time. And then it basically, we can call the function this way. Okay, and it will match exactly this. Okay. All right, so, and also sometime that you can actually include some parameter that in the template to actually provide some logic that needs those input at the runtime. So for example, that this is a template, you can see that I have a type name t, but then the other two, which is integer upper, integer lower, they're not type name. They're just parameter for when I want to call this template that I will actually need to provide some number. So how would that number be used if you can think about that upper and lower, that this one is a function called is in range. It's basically comparing whether the input argument is actually indeed smaller than the upper bound and the greater than the lower bound. So it's a range check. Okay, it's try to check that. So I actually have a template over there. So when you call it, it's actually called in the middle. You can say is in range. In this case, you have to explicitly to match the template instantiation. So you say double. The type name is going to match the double. But then what you say, the upper and lower, you're going to provide an upper bound and lower bound, say 500 and 0. And then you provide the value over there. So this, when you actually do the middle line with that template on top, that you essentially, the G++ compiler is going to essentially generate a code in the sky blue box down below. If you look at this code is going to return a bool because because the template says the return is a bool, and the name is in range, and then it takes one argument, which is a double, as specified by the template. But here's the interesting part is that because the template has upper and the lower, and you specify upper is equal to 500, lower is equal to 0. So the compiler is going to take that information and generate a code, say arg value is smaller than 500, and arg value must be greater than 0. So that's the way that you can parameterize even your type name area such that you'll be able to provide the information to customize the function you like to template. And which is very useful because a lot of chance that you don't know this number until the people try to use it. So the people who design the template, they can just put those parameters to allow the user of the template to actually further specialize into their template. Okay? All right, so I hope you have some basic idea about what function template is and how you can use that to actually develop your own logic into the template format. So I'm going to talk about the other concept is called pointer to function. All right, so obviously that in C you could have a pointer, and usually our pointer are related to the data. Means that what's the address? I would say more specifically, what is the address of the first byte of the data object we're interested? Okay, so that's a pointer. That's an address of the first byte in C or C++. So now we can generalize that concept to a function, a piece of code as well, because if you can imagine when I talk about memory address, I use that memory to host my data. But I also use memory to host my code as well. So the thing is that since function is a segment of a code, it's somewhere in our memory, then function pointer is essentially the memory address of the entry point to that code in execution. Okay, here is an example. So for example, in the middle, let's look at the middle. I'm actually talking about a definition. How do I declare a function pointer? So in the button, I have this function which we just show in the previous example is checking the range. It's called is in range. And this function, this is what we call function prototype. It returns a Boolean, and then its input argument is double. So that's the function prototype for this particular function. So now I'm going to define a function prototype, a function pointer that's going to matching that function prototype. That's what I did in the middle. I said bool, and then I have a pair of parentheses and put a star func point. Means that the func point is a pointer, and then I have a double. So you can see that this looks like it's a function call, but indeed, when you look at this, this is a declaration of a pointer to a function. Okay, but by the time this, I'm just defining the type as a pointer to the function, but I haven't talked about how do you assign the value, which I will show you the example. So here I'm going to first tell you how to do declaration of a function pointer. Just like I declare this is an integer, here I'm declare this is a pointer to a function, but I haven't actually assigned any value. So the syntax, as I put it in the yellow box here, is first you specify the return data type of this function. And then you have this parenthesis with a star, then that's the variable name. The variable is a func underscore ptr, which is a variable, just like int x. X is a variable name. Here's a variable name is func underscore ptr. And then the rest of this is essentially part of that function prototype you need to match. So in some sense, a list of t argument is going to match with a double because it only takes one prompt argument, and that argument is double type. But you can imagine you can generalize this to have matching multiple argument if you have that. Okay, so that is the way how we declare a pointer to a function. Okay, let's see how we can use this. Okay, now I have this piece of code. This function is called isInRange, as we have seen that many times, and this is now I already include the range is 500 and 0, so now I can do this. Okay, so now you see that the first line here in the main, the first line under the main function is that declaration. So basically I declare whether whether func pointer is actually a pointer to a function which take a Boolean as a return type, and it will take one argument, and that argument is going to be double. So that is my declaration line. And the second line is interesting. When I declare it's a pointer, I didn't assign the value. So that pointer is not usable at this moment. It's just saying that the data type is such and such, but I haven't done anything to that. So the second line is very important. The second line basically say now I can assign the value. You see that I put the function name is in range into that pointer. So I can actually assign that. After that, essentially func pointer is representing the address of the entrance code to that function is in range. Okay, so I now assign the address to that function pointer. Third thing, now I can use this pointer to call a function. So instead of for me to call is in range, I can just say star func pointer. You can see that I'm actually just calling it in next statement and then put the parenthesis 35.0. Okay, so that's the way for you to declare a function pointer, for you to assign the value of function pointer, and how do you call it. Okay, you need to have this 3-step. You have to declare it, you have to assign the value, then use it. Okay. All right, so what we have here is that, okay, now we can do a little bit different. Remember earlier we talked about we can do, instead of using function, we can use function template. So we can use this template and then to define this function called isInRange. So let's try to combine these two concepts together. We have a template, we have a pointer function. Let's try to combine these two together. We can do that as well. Okay, so now you can see I replaced that function from our previous example. Instead of a function, now I'm actually providing a function template of exactly the same function. You see that I'm actually doing that, change that on the top part. So now let's look at the main function. How do we do this? Very similar. Number one, we still declare that function pointer func underscore ptr. So exactly the function prototype, I can actually do that. Okay, the second line is interesting. The second line, I'm actually using the function template representation on the right-hand side of the assignment, and on the left-hand side, I'm actually using that function pointer. So essentially what I'm doing is that when I call this, if you look at the way I write this line, is in range and small sign double 500 0 greater than, I didn't have that parenthesis after that. So which means that this is not calling it. This is not calling the function. This one is just tell the compiler, hey, I need to use this. Please generate the code for the template under this condition double 500 0. Okay, so once you have that, the compiler already have that function somewhere in your memory. Oh, this is important. Now you see compiler and the memory. Compiler is generating that. If you don't have that, compiler won't do that. So because when you do that, when you have the instantiation, it starts to occupy your memory, and then you need to have a memory address. So that's why it's a memory address. Now you can actually assign that instantiation memory address to your function pointer. And now the function pointer is actually valid, it's actually being assigned, just like what we did previous slide, that you assign as is in range. But now you can see that I'm assigning from the template, not from a function. And then you can actually call this function just exactly like what you did before, and you actually get the same result. But there was one thing I just want to tell you is important. This slide, I actually did one thing after that calling with 35.0 as argument. I actually print out the address of the func ptr, because function is also in the memory, in which the function generated by the template is also in the memory. I want to know where it is. That's the privilege of C and C++ programmer, that we got to see where it is precisely in this virtual memory address space. And if you do that, I encourage you to try this program. And this is on my computer. I'm actually getting that address. And you can actually, if you remember our previous assignment, that address, I give you a hint, is very close, fairly close to the same region which you have your virtual table or virtual function address. Okay, so that's you can see that, well, I can really combine template, function pointer together, and I can now manage pretty powerful code. Okay, so far we actually covered this two. So we covered this two concepts. One is called template, which allow us to express a logic cover a broad range of input data type or return type. And also we allow us to provide different parameters such as upper and lower for us to customize the logic when I want to invoke this template. On the other hand, I can actually also define function pointer which work together with the template, which we will see more example. But before that, I'm going to introduce another concept which is called Lambda Expression. That this is the topic that cover in chapter 9 of your textbook. So what is a Lambda Expression? Lambda Expression is also a function. It's a function, but it doesn't have a name. You will see, oh, that's very strange that you have a function like is in range is a function, min is a function, dump j is a function. There is lots of function that must have a name. But Lambda Expression is interesting. It doesn't have a name. It doesn't have a name. And I think you will say, well, why is this important to come up with this concept called lambda expression that you can specify function without a name, I would say that it's a very nice way. It's very useful when you want to pass the a function as an argument, and sometimes using lambda expression is very important. And then we will see that lambda expression is quite useful if you want to create some function template or even class template together. Okay, so let's look at some example. So here's the first example. We're coming back to our favorite function, which is now doesn't have a name. It was called isInRange, but now we don't have a name. We just call this a function. I call it IIR. I even forgot why I call. Oh, isInRange. That's why I call it IIR. And essentially, I define IIR as auto. Auto means that I don't even want to specify the type of IIR. Compiler, please help me to figure that out. Okay, that's what auto is kind of lazy fashion of writing your code, which is fine with me. All right, so you basically say auto IIR. What's IIR? Is equal to blah 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 on the right hand side of the assignment, and which I don't want to talk about that right now, but take that. That is a what we call lambda expression for exactly the equivalent function that we have been discussed earlier, isInRange. Okay, that's equivalent the code over there. And then after you assign this lambda expression to that variable IIR, and then I can just call it. Just like this, I call this IIR with 35.0, and it will work. Okay, so essentially what I'm doing is that I didn't even define this function isInRange. I'm just using lambda expression to specify the function, and then I basically just call it this way. Okay, so now let's actually look at the lambda expression itself. Okay, so I'm going to first use this example, then go through more detailed example. So the first thing about a lambda expression is what we call lambda introducer. So lambda introducer is a pair of bracket at the beginning. So if you have a assignment, right after assignment or right after the right context, you have that a bracket pair, then we know it is now the following until you hit the semicolon at the end. Is going to be a lambda expression. Okay, so it will be interesting to know that I just advanced. I said normally in a lot of cases you won't have anything within that bracket. Okay, but in some cases you can have equal sign and and signs, which represent I would say a call by value, call by reference. But we'll talk about that later. Okay. So, okay, right after that introducer is what we call the parameter specification. So that double argument value is represent this function is a nameless function, it's still a function. So a function has to have an input argument. So this is the area you're going to put your input argument, that this input argument is double argument value. Okay, here's the interesting part. Now you see that hyphen greater than sign. So, I mean, I have to say that sometimes I'm not sure why they want to do this, but this is not a pointer. Okay, this is not a pointer. This is basically say what is the return type. So when you say see hyphen greater than sign and whatever type after this, it means the type of the return of this lambda expression or lambda function. Okay, after you specify the return type, I mean, if you don't have a return type, then you don't have the hyphen greater than sign. Okay, that's fine if the return type is void. And then you will see a pair of curly bracket. And within that curly bracket is the body of the function, is the code of the function. And then, of course, you have a semicolon. So this is how you can parse a lambda expression. So more specifically, that now I'm showing you the code isInRange compared with this lambda expression representation of isInRange on the top. Okay, so you can see that I have the introducer, which is a pair of bracket. I have the input argument, I have the return type, and then I have the function itself. And that's it, okay? All right, so this is interesting. But I do want to say that, okay, I just want to tell you, I just named those 4 areas: introducer, argument, return type, and body. Okay, just remember every single Lambda expression, you should have all 4 of them. If you don't have a return type, you don't have the number 3, but you should definitely have a number 1, 2, and 4. Okay, that's how you're going to do that. Okay, so now I'm going to do something a little bit different. All right, so this is a function I showed you earlier. This is a code which is essentially I have a function prototype called isInRange, and I basically using the function pointer to actually instantiate the template isInRange, and then I basically ask you. I already showed you this code before, so this is not a new slide. Okay, but I just want to remind you what we have. But now what I'm going to do is I'm going to actually change this. Instead of using function prototype, I'm going to use the Lambda expression. So the Lambda expression will look like this. Okay, it's nothing surprise, right? I'm still defining the function pointer, and then now I want to tell you that earlier I used auto, but now I'm not using auto because I know that this Lambda expression is actually matching with my function prototype for func pointer, so I just directly assign to this. So you can see that now I assign a expression into the func pointer which I declared earlier, and then I just call it using the way I call function pointer. So now I can use function pointer exchangeably with the Lambda expression. But one thing I do want to say is I actually also print the address of the function pointer, which means I print where compiler allocate memory for this Lambda expression. So in other words, even though this Lambda expression doesn't have a function name, but it has a memory presence inside your memory. And that memory address is also not too far away from the memory address we have earlier. Okay, so I hope you understand now how do you declare a Lambda expression, how do you actually work together with a function pointer, and how do you call it, okay? So now I'm actually going to do something even further, is that now I'm going to add complexity and such that I'm going to put function pointer together with Lambda expression, which, by the way, is probably the most powerful things you like to do with a function template. I mean, a lot of time, a template is try to handle different type of object. But the thing is that different call to the template want to do some kind of customization. Like we earlier talked about, you set the upper bound and lower bound, so you can actually be able to change the behavior of function. It's almost like a polymorphism, but it's for the template. But one level advanced than just adding 2 parameters of upper and lower is that I just actually input the Lambda expression as one of the arguments in the template. So when people call it, people actually need to provide a function or equivalent, a Lambda expression as argument. So not only I can handle different type, but I can have a function that could handle this differently for each call. So this provides us a lot of flexibility. By the way, I should actually not getting too excited because this potentially causing problems as well if you're not careful, because you're basically providing a template is not just have the flexibility of the basic type, but you actually customize the logic for every single call you to the function template. Okay, so every time you call this template, the behavior is going to be totally different if you give a very different Lambda expression. Okay, so let's see how it works. So we define the template. So now my template has two type name. One is a T, one is a F. Okay, and the thing is that I just defined the template. By the way, the template, they are so smart. They don't even know the F is a function prototype, is whatever. It doesn't care. Okay. But the thing is that what it does know is that when you input this, you specify T as argument value, and F is a my lambda. I just call it my lambda. You can call it argument lambda. You can call whatever name you want. And what it does is that inside there, I just use that pointer, use that my lambda as a function name, and then I just call it. And that's my template. So you can see that this is essentially taking two arguments. One argument is a variable, the other argument is a lambda expression or function, and I just shuffle that value into that lambda expression and return whatever it returned from that lambda expression. So this is a very simple template, but you can see that this can be generalized to cover a lot of cases. Okay. Okay, so now we can see how are we going to call this template. So now this is interesting. Have you noticed the code is getting shorter and shorter? Okay, so right now you have the is in range. It takes two parameter. Now remember, because template, the first one is a double. The second one is a lambda expression. So the first one is going to be double, is going to fit in that type name T. And then you have that whole string that the compiler know it is a lambda expression. So it will change that template to become a lambda expression input. And then the compiler know how do I interpret that my lambda. So that's actually very powerful. Now you see that how your function template can be used together with the lambda expressions. Okay, so I'm going to show you a different way to look at this very complicated statement about is in range. Is that instead of looking at the whole thing, it's really just like the way when you parse the JSON string, it could be really complicated. I mean, I hope I can have a style of the string function to print out the lambda expression. That's probably my biggest complaint to lambda expression. Is you have a two parameter 35.0, and then you have three sessions. The first session is after the lambda introducer that you have a the argument is double argument value. And then you have your return type, which is a Boolean, and then you have your function body. By the way, the second parameter is not a call itself. Is really a lambda expression, is equivalent to specify a function without name. And the real calling of this function is inside that template. So inside that template, you're doing my lambda argument type. Okay, so that's how you can see you're putting template and lambda expression together. All right, so now I'm going to show you the final example in this lecture. Is that we're going to combine the three things together: template, pointer, and the lambda expression together. So this is actually this example you can see here. So now my template is a little bit different. My template, instead of saying that it's just a type name T, if I'm so clear about what will be my function that I would like to pass in, I will just specify that function as a function pointer. So now you see that the declaration in my template, it is a function pointer declaration. It's basically say my lambda is a variable and the type is a pointer to a function with the following prototype. This function prototype will return a bool and it will take one argument as a double. And then inside this function template, I would just call that using the function pointer calling convention to call it. And then in the main function, I'm actually not even change one character. I'm just using lambda expression in the second argument, it will automatically match with that function pointer. So in other words, I'm saying function pointer and the Lambda expression, they really go together. They're really the same thing. I mean, it's interesting that this code, when I wrote the code, you can try this. I have a 2 in my template. I have a 2 my lambda over there. And my lambda, I both put a star sign before the my lambda. The interesting thing is that if you remove 1 or 2 or both or whatever order you want, the result is the same. So it's interesting, at least with my G++ compiler, I was actually quite surprised and trying different combination. And it doesn't matter because they're the same. The compiler know whether you have a star or not a star, they know you try to call that function. Okay, so just let you know. Okay, the last thing I do want to mention a little bit is about lambda introducer. I mentioned this earlier, saying that the introducer, it could be just nothing. In this bracket, this is what we call a default, which means that when you have a default, means that whatever your function body within this lambda expression is independent of the scope you're in. So by the way, you're going to call this function somewhere and you're within some scope. But if you're actually inside this default introducer, then basically you're just like a new scope to yourself. And you cannot access to anything outside and nobody can access anything inside. Okay, so it's independent. Okay, now you have 2 other options, which you have to be careful, know what you're doing. I think you just need to be careful. I mean, if you put an equal sign, which means that this lambda expression will be able to read only access to any variable within the same scope. So where you're going to put this lambda expression, it actually can look at some of the code within this same scope. Okay, that's useful, but that's also introduced some concern. But the most dangerous option is put the M sign. The M sign is basically say your lambda expression can not only read, but it can write, can modify the value. It's like a call by reference, essentially. So essentially, this is a different option, and you should really find when to use which option. Most of the people using Lambda, especially with template, they're actually looking at the first option only. Okay. Okay, this is what we talk about today. We talk about a lot of things about function. They all related to some kind of flexibility in defining function over a variety of situation, and yet they have some commonality that we can use this concept called template to solve this problem. And the template can go together very nicely with both pointer and lambda and pointer to function. They're also equivalent to each other. And this together, you can write really, really powerful code to do something which is very generic, and yet it can handle all kinds of situations. Okay, so that's my introduction to function template. So in C++, there are 2 kinds of template. One is the function template, but the other one is one further up is called class template. And the class template is really interesting because it allows us to build. In fact, you already start using some of the template, such as the template you use in the standard template library, such as std vector or std map. And those templates are very useful for us to handle the generic. So we're going to see that in the next lecture. Okay, see you.